Hi everybody, in this video we are going to do a quick crash course on how to transform graphs. Specifically right now we are going to be transforming the tangent function. So if you just saw the other 4 videos for sine, cosine, cosecant, and secant, you would notice that for those I only focused on the quadrantal angles. However, for tangent and cotangent, I'm not only going to focus on the quadrantal angles, I'm also going to focus on the angle in the middle of each of the quadrants, which are going to be the increments of pi over 4, essentially. So here I'm going 1 pi over 4 if you count it around, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. But I'm going to use those. Ooh, that highlighter is not great for this. Oh, that's okay. So these are going to be my input values. The reason I need more than just the quadrantal is because the quadrantal don't give me really enough information to draw out the branches, as you will see. And I already have it set up for us down here on the page. Now let's quickly also point out another big difference in the first 4 with the tangent is that the period for tangent and cotangent is just pi over b, not 2 pi over b, because tangent, it only takes half of the circle, the unit circle, for the output values to start repeating themselves in a pattern. So the period is pi over b. When you draw it yourself, you're going to use 9 tick marks. So first, last midpoint, that's 3. Midpoint, that's 5. Midpoint of those increments, that's 9. That will enable us to draw 2 complete cycles instead of just the 1 period. We're going to actually have 2 full periods drawn out. It's helpful, especially with tangent, because it doesn't look like much. You don't really understand the full scope of what's going on unless you really draw 2 cycles. So I highly recommend. Now, what does tangent equal? Tangent on the side, if you know my comparison. Oh, the video's a little messed up here. I don't know how to focus it, so I guess I'll be blurry the whole time. Oh, there we go. If you know my tan, the meditating man, he's meditating, he's holding zeros on the side. The zeros are indicative of the zeros on the sides of the unit circle. So what does tan equal here? Tan equals 0, 0. And when he's meditating, he's clearing his mind, and everything in his mind is undefined, and he's thinking of all the people that walk the earth and how he can't define them. He's wise and he's better than that. He will not define. So undefined on top and bottom. Now, this is what I mean when the quadrantal angles don't really give me anything. They're 0 and undefined. Like if I go over to my graph, let's jump over to my graph. Oh, Smudge City. Oh, I hate that. Sorry. Okay. So if I go over here and I'm like, oh, let me put down everything I just learned onto my graph. Okay, so it equals 0, at pi, and at 2 pi. Cool. And it's undefined at pi over 2 and 3 pi over 2. Tangent has 2 vertical asymptotes, just like secant, and then cosecant and cotangent, number of syllables matches. Okay, that's nothing. I can't draw anything. I need more information. Okay, are you picking up what I'm putting down? So I need more information. What is that information? The tangent value is at least 1 per quadrant, and these are the best ones to get because these are pretty easy. What's tan equal here? 1 and 1, if you remember from earlier in your trig studies, and then tan is -1 and -1 in these 2 places. So if I go back to my graph and now put those corresponding points down, 1, 0, and -1, right? 1, -1, 1, -1. There we go. We have more information to draw. It's going to look like this. If you only draw 1 cycle, one of the periods, like you're only going to see that, and it kind of looks like the reciprocal function a little bit. You know, but really this is continuous to there. It looks like that. Okay, and then this goes down. So now you kind of see like a cubic curve happening, and this is going to keep going forever. Symmetry, as I mentioned in I think the last video, the symmetry here is odd. Okay, if I rotate 180 degrees, yada yada yada. Domain, we could do exactly like we did for secant and cosecant, all real numbers such that theta, that's a Q, Jesus Louises, such that theta does not equal asymptote, which is in this case pi over 2 plus how far apart are they? pi over 2 to 3 pi over 2, that's 2 pi over 2. So in this case, it's pi n, such that n is an element of the set of integers. And the range is actually from negative infinity to infinity now because it's smooth, continuous, up and down. Beautiful. As for this, as lackluster as possible, try to get this done. K plus absolute A, K minus absolute A, H, and then plus Q, forever, because we're going to add quarter periods 8 times. Domain is all real numbers, such that theta, oh my god, how many times have I done this? Like 4th or 5th time already. Theta does not equal, so it's really H, those are little quoties, H plus 2Q, should probably be a parenthesis, what am I, quoties, what am I doing? H plus 2Q plus, how far apart are they? 1 period apart, N, where N is an element in the set of integers. Eek. There you go. Hopefully you could, I said it, hopefully you could read it and correspond to what I said. And the range is negative infinity to infinity. Then negative tan, what will that one look like? Same asymptote. So it goes 0, every other asymptote 0. Asymptote 0, and then this is flipped over. Should pass through that. Concave up, concave down, concave up. So there's negative tan, and similarly to the one I just drew a second ago, going, oh boy, I should have, this is why you should plot that point. Concave, concavity, point of inflection switches right there. Wow, I'm so sloppy right now. I'm so sorry. I'm hungry. Can you tell? I'm like not functioning correctly. I need to eat something. I need to take a break from this and eat. Whenever I don't eat, I get real, not myself. Like a Snicker commercial, but not angry. Like I'm just like, I become real stupid. That should be Snickers' next campaign. If you're out there, Snickers, I need a snack sometimes because I get real dumb. I mess up my words, my writing. I say all the wrong things. I combine words and sentences together, or I get brain freeze a little bit. All right, that's it. That's the gist. Got the gist? Let's go. Positive tangent graph, so I can just get it going. It goes 0, asymptote 0, asymptote 0. Then it goes up first if it's positive. Boom, drew it. Did all the hard stuff. Now, using our equation, let's label. 2 is here. That's a half, so this is 2.5 and 1.5. Pi over 12, it's minus, so it becomes positive pi over 12. I don't know if I need a common denominator, so I'm just going to write pi over 12 on the side. Period is pi over b. Don't forget, everyone forgets. Pi over b, so it's pi over 6 sevenths, which is 7 pi over 6. That's your period. So then Q will equal 1/4 of 7 pi over 6, which is 7 pi over 24. So that's the Q. So that's going to be 2 pi over 24 when I get a common denominator, and I'm just adding 7 to the top. 9 pi over 24, 7 more gives me 16 pi over 24, 23, 30. If I mess up over here, it's like I said, because I need a snack. I need to eat. 44, 51, 58. There you go. Domain and range. Domain, all real numbers such that theta, I did it right, does not equal 16 pi over 24 plus the period, which we said was 7 pi over 6n, comma, n is an element in the set of integers, and the range is from negative infinity to infinity. Boom. Pretty good time. 10 minutes, almost exactly. Thumbs up, thumbs down, comment, question, concern, something, anything. Appreciate it. Appreciate you. Hope you appreciate me. Next one's cotangent. Adios. If you need more help, go to the other playlist with more trig stuff.